Hi everyone and welcome to this lesson. Today we'll be looking at a parabola, which is our quadratic function. And in this example today it looks like this. Fx is equal to ax squared plus q. So in this example it only consists of x to the power of 2 term, which is our variable term, plus a constant term. There is no term that has an x to the power of 1. So that basically means that in these type of examples, our parabola will only move up or down. There is no left or right movements, as you will see in the following lessons. So keep in mind that when we have only an x to the power of 2 term and a constant term, there is only up and down movements of our parabola. Now let's have a look at what these variables mean. Well, this a, which is the coefficient of the x squared, well, this a teaches us whether we draw the parabola with its legs pointing up or down. So if a is greater than 0, so in other words, if a is greater than 0, our legs are pointing up. Now, what does it mean if a is greater than 0? Well, a is equal to a positive number. So in other words, we draw the parabola with the legs pointing up. And if a is less than 0, we draw the parabola with its legs pointing down. In other words, this a will then be a negative number, so we draw it with our legs pointing down. Got it? So if a is less than 0, this a is actually a negative number, and we draw it with the legs pointing down. Now, let's have a look at this q. This q teaches us whether the parabola moves up or down. So if we look at the following example, we can see that this turning point is right here at the origin. Okay, so the coordinates is 0 and 0, because then this q will have a value of 0. But as soon as we give this q a value, for example a 3, this parabola will move 3 units up because the q will be positive. If it is a negative value, so a minus a certain number, this parabola will move downwards. Got it? Okay, excellent. So let's go and look at an example. Now here is our Cartesian plane, and we are also given this quadratic function. Now we want to draw this quadratic function or this parabola, but before we start, it's very important to kind of have an idea in your mind what it should look like. Now let's quickly look at this function to see what we can derive from it. Well, we have a term that is an x to the power of 2. Okay, so great. That means that we are busy with a parabola. There is no term that has an x to the power of 1. So in other words, this parabola does not move left or right. And we have a constant term. So this constant term teaches us that this parabola only moves up or down. And in fact, it moved 4 units up. So, because this a, which is the coefficient of the x squared, is also a negative value, it's a -1, we know that the legs will be pointing down. So, we kind of have an idea now what it should look like. So, let's go and plot the first point. Our parabola moved 4 units up. Okay, so that means on our Cartesian plane we can make our first dot right over there on the y-axis, because this parabola only moved up 4 units. So the coordinates will be 0 and 4, and the x-coordinate will automatically be a 0 because we're on the y-axis. Okay, great. Now because this a value is negative, we also know that the legs will be pointing down, and it will cross our x-axis at 2 points, which is called our x-intercepts. Now, how do we calculate the x-intercepts for a quadratic function? Well, we want to calculate the values of x. And to do that for a quadratic function, we are going to have to factorize. Now, here is a small bit of advice. When we factorize a quadratic function, we never want the a value to be negative. So our first step is to take out this minus as a common factor. So here we go. I take out the minus, and then you know how it works. It's minus x squared divided by a minus gives us x squared, and plus 4 divided by a minus is minus 4. So we took out a minus as a common factor. Now we are ready to continue with our factorization. Now, when we have our x-intercepts, we automatically know that the y-coordinate is a 0. So we make our y a 0, and now we work out our x values. So this part in brackets we can factorize because this is a difference between two squares, and I'll quickly run you through the method. So the square root of x squared is an x. We write the minus, the square root of 4 is 2, we put it in brackets, then we rewrite this bracket exactly as it is here, so x, but instead of a minus we put the plus and then the 2, and there is the difference between two squares. Now this lesson is not about factorization, so if you are unsure, go and have a look. Now we still have the minus at the front. But since this is now an equation, because the y is a 0, we can get rid of this coefficient in front of these brackets, so we can divide with this minus on this side. So we've got 0 is equal to, now we don't have the minus there anymore, and we only have these brackets left. This is our zero product rule, and you know how it works. So in other words, our first x value is equal to 2, or the other x value is equal to minus 2. Got it? So now, we have our two x-intercepts. So our first one is a 2, so it's right over here. So our x value is a 2 and our y value is a 0. And our other x-intercept will be minus 2 and 0. And now we simply connect these dots. So there is our first line, and there is our next one, and that is our parabola done. Now, before we continue or before we finish off this lesson, I just want to quickly remind you about the line of symmetry. Now, what is a line of symmetry? A line of symmetry is a line that divides a graph into two equal parts. Now, a parabola has a line of symmetry right at its turning point. So in other words, here I'm going to draw it in as a yellow line, and there it is. And this line is our line of symmetry, which divides our parabola into two equal parts. Now, it's also important to know how to find the equation of this line of symmetry. Well, this is a vertical straight line, and it goes through the x-axis at 0. How do we know? Because it's on the turning point and the x-coordinate is 0. So in other words, this symmetry line's equation will be x is equal to 0. We covered this in our linear lessons where we looked at vertical and horizontal linear lines, right? Okay, excellent. So I hope you could follow. There's a couple of important things mentioned in this lesson. Work through it and see you again next time. Bye.